Now, the next question, moving to GC this time, from our video GC Troubleshooting, the most common problems you will encounter. And they ask, what could be wrong if my inlet total flow falls when the oven temp is ramping up? I have changed the septum.
Okay, wow. So the total flow, so we're talking GC. If you look at the inlet, we could measure what's called total flow. Total flow coming in, we really measure coming in, it's really three things going out. It's the column flow plus the split flow plus the septum purge. Right? Those three things add up to total flow. Now, what's going to happen is, gets a little obscure, but it's a really important point. And that is, in the GC world, there's two modes of operation. They're called constant pressure and constant flow. Now, in the olden days, all GCs were constant pressure. That's all we had. And then in the 1990s, we had the invention of what allowed us to use constant flow. It's called EPC, electronic pressure control. So that allowed us to move to a much better system, and that is constant flow. So here's where it makes a difference. If you're doing a temperature program, if you're running constant pressure, which is the default of instruments still today, constant pressure means you're putting a pressure on the head of the column, let's say 20 psi, and you've determined that pressure gives you your favorite flow rate. You love that flow rate. But as you heat up the column, the helium, or whatever gas you're using, helium, hydrogen, nitrogen, gases become more viscous with temperature. So as you heat up the column, the mobile phase becomes more viscous, and the pressure you're putting, the 20 psi you're pushing on now, is going to give you a slower flow coming out the other end. It's sort of like if I have a straw and I ask you to draw water through the straw, it's not a problem. If I ask you to draw honey through a straw, it's going to move a lot slower, right? That's because honey is more viscous than water. Well, in GC, hot helium is more viscous than cold helium. So as your column temperature is increasing, if you're running constant pressure, your column flow is actually decreasing. So now to notice that in the total flow, I will admit, I think it's a little odd. I shouldn't say odd. Typically, for most applications, I'm running 1 mil a minute through the column. I'm running 100 mils a minute out the split vent. I'm running 3 mils a minute out the septum purge. So you do that, add all that together, and that's 104 mils a minute. If that's my total flow, I'm looking at 104. If my column flow drops, it'll drop from 1 mil a minute, maybe down to a half a mil a minute with a wide temperature program. Then my 104 dropped to 103.5. See what I'm saying? That's a little, boy, good for you for noticing that, but I think that's a little odd. Now, if your scenario where you're running a megabore column, you're running 10 mils a minute, and you're running a 2-to-1 split, so your total flow is more like 30 mils a minute, and your 10 drops from 10 to 5. Oh yeah, that's where you would notice it. So big step back. In the GC world, there's two modes of operation: constant flow and constant pressure. In my mind, there's one right answer, and that's constant flow. Constant flow will always give you the best results. Constant pressure, you're fine. Unless you're doing a temperature program, then you're sort of putting yourself at a disadvantage. Constant flow always gives you the best results. You will find this in your method. So go to your column, whatever the column part is in your software, and under column, you'll have a flow versus pressure, constant flow, constant pressure, and that it'll highlight one versus the other, and that is how you determine what mode you're running in. So everyone, switch to constant flow, ready now, and I promise you won't be disappointed. Great question.